Today we're working on making a modular die system for the power hammer, as well as improving my work from 10 years ago by making a new leg vise stand. Today's episode is sponsored by Trade Coffee, which is fantastic because I love coffee and I get to enjoy Trade Coffee every single morning.
Alrighty, we're gonna try this coffee from the Stay Golden Coffee Company. Oh, that's a win for me. I like that a lot.
With lockdowns all around the world, invariably we're not going out to get our favorite coffee at the local coffee shop so much, and so you might be making more coffee at home, which is why you absolutely have to check out Trade. It works like this. You take a super quick quiz online, answering some questions about how you like your coffee, and then Trade pulls up a selection of coffee that you might well like. You can then get the coffee delivered to your door. You can choose the delivery frequency you like. You rate how you liked that coffee and repeat. Trade guarantees that you're going to like the coffee they match you with. So if you don't like the first bag, they'll ship you out a new one for free. Trade has partnered with a bunch of coffee roasters all throughout the US, so you get the freshest coffee when you shop with Trade. And by going to my link down in the description below, you're going to get 30% off your very first bag of Trade coffee. It's a hell of a deal. Thank you, Trade, for sponsoring this. Check out that link down below. Let's get back into the video. All right, let's get these dies out. Oh. Check this out. I didn't know what this was at first, but there is a sliding plate that stops the key from coming out. I've never seen something like that on a power hammer die, and I think that is just so ingenious, because if that key came out on this machine, you'd be running that key into this part of the power hammer and you would break things. There we go. Ooh, all right, give these a clean. God, it's just years of crust on this thing. I think we'll take it with the wire wheel. Let's see how this system works, because we've got to take it apart for our next step. Oh, I love this. That's just such fantastic, simple engineering. This is a feature that could be installed in any power hammer die incredibly easily. That's just beautiful, simple mechanics. I love seeing these things. Let's see how hard these dies are. Okay. That feels fairly hard. That feels fairly soft. I'd say the top die is much softer than the bottom die. And I'm saying that because this has the desire to skate the file a little bit more, whereas this one is allowing me to bite in a little more, slightly lower tone to the ear too. But they're both a little harder than they really need to be for our next step, because our next step will be explained once we put these in the forge to anneal. I'm putting a center punch mark in them so I know the orientation they go in the machine. Well, the top die is definitely softer than this bottom die because we just flattened our center punch trying it here. This is fully hardened. Righty-ho. Ooh, these are hefty chunks of metal. So while those pieces are annealing, it is on to the leg vise. Let's make a new stand. This tips over. The base isn't wide enough. It's also probably a couple inches shorter than it needs to be. I did make it when I was 13. So we're going to lift it up, make a base with a wider footprint, and I'd love to get some wheels on it too. We're making progress on the leg vise stand, and have a look at these dies. They're nicely up to temperature. So we're just going to slowly let them cool down. Right, let's start work on the legs. Now, Jamie just asked, Jamie's in the workshop today. How are you, Jamie? In that this might be too wide to fit through the door into the grinding room. 900 millimeters, 820 millimeters. Shoot. Let's see what it looks like on the ground. Oh, I think it looks very good, but I would love it to be able to go through a door. So I'm going to try and take these legs
and then move them inboard a little bit. We'll see how it looks. Hopefully it still looks stable enough. The main priority is that it's very stable. So back in December when I made the stand for this anvil, and I filled the legs with sand, it took me about an hour and a half. The reason being, when I bought the sand, it was actually quite moist because it was stuck outside. Well, I want to put sand in the legs of our leg vise stand as well, and the reason we do that is it adds a little bit of weight. It also deadens that really loud ringing sound. And though the sand that I have is now drier since it's been inside this workshop, I'm going to fill it before we weld the feet on. Alrighty, with the feet welded, with the leg vise bolted on, it's time for us to think about locomotion. I would love to be able to have this thing relatively easily move around when wanted, but not relatively easily move around when not wanted. So I have the idea of using some wheels. It'll be partly inspired by seeing this. This is a wheeled stand. My father gave me this, he had one spare. And you'll see it's got wheels on it, awesome, but then you flick this little lever, and it drops down onto the ground and it's nice and solid. But it's also inspired by Jimmy DiResta's mobile anvil stand. That is a really cool setup. That is slick, look at that. I don't think mine's gonna be as fancy. I think I've actually come up with a relatively simple solution that might potentially work. How cool does that look? So I think I've got enough progress to now show you the concept. We have this triangular frame with our casters. Then we have ourselves a hinge over here, a barrel, pin. This triangular frame pivots on the barrel. We push it down, it lifts the vise up and allows it to be on the wheels. That is going to work a treat. Look at that, it pivots. All right, so it's the moment of truth. We test it. It feels nice and solid right now, but if we actuate our super handy dandy wheel activation device, we give it a push. We put our special stick down. We now have a perfectly mobile leg vise stand. This is awesome. Let's see if it gets into the grinding room. Moment of truth. Oh, and it just squeezes through. We're in! And it's now ready for some use. Oh wait, shoot, it's absolutely not ready for some use. Look at this, it's a leg vise. Part of the reason you use these as a blacksmith is because you get to transmit force down through the leg. Well, look what I've gone and done. I forgot to put the spacer in here. I have to make a thing that's going to transmit the force down, and I forgot to do it. Well, folks, I dare say, I think we've got ourselves a mighty useful leg vise stand. This is everything I hoped of. So yesterday, you saw we put the power hammer dies in the forge. Well, we got them nice and hot. Oh boy, they're heavy. And we hopefully let them cool down slow enough that they're annealed. Fortunately, not too heavy of a scale coating. So the plan is to turn these dovetail dies into some slightly simpler modular dies where I'm going to easily add inserts by cutting off a bunch of material on the top of each of these. And then once that's been cut off, drilling two 16mm holes. And then on the side of the die, drilling and tapping two 12mm holes so that we'll have a bolt that tightens pegs on the bottom of die inserts that go in these modular thingamawhatsits. One important step we shouldn't miss is just making sure that they are indeed soft after the trip in the forge. And they feel pretty good. That feels machinable to me. I've always wanted to try spray blue Dicom, so you can imagine how I felt when they only had red. If this works, I'm gonna be very, very happy. It almost made it the whole way through. The saw bottomed out with that much to go. That's an admirable cut. It looks like it's just come off a Blanchard grinder. Question is, can we fit this big one in there? I think it'll just squeeze in here. This is ridiculous. We bottomed it out from this way. Gotta flip it over. Woohoo! Yes! That's insanity! To the mill. Let's try out this face mill that came with the Bridgeport.
We are going to need to expose some fresh tips though, because these are a little chipped.
Not a very difficult task though. Little unscrew there, little turn around, back in we go. Same with all the others. This whole setup is just ever so impractical. Look at this. There is maybe 100,000ths of an inch, maybe 2 millimeters of holding grip with this back vice jaw. I had tried to make 2 bits of round bar to get in there, hold it on the round bar. Well, the vice doesn't open anymore. It would be quite risky to try and grip it like this, but it might be what we have to do. That looks utterly ridiculous. Let's try a smaller round bar. There we go, that's a little better. Wowza, that's a nice surface finish. We've got one hole down, and as you will see right now, this machine does not have what most of my Bridgeports have had, which is a digital readout. I'm pointing up here because it would be here. And so some of you might be wondering, how exactly am I going to be plotting out my hole centers accurately? Well, on these dials, we have lines that correspond to the amount of travel that this table will make by turning the screw. 1 full revolution equals 5 millimeters of travel, so I know if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wait, is that 12 or is that 13? And then compensate for the backlash by finishing it off in the same direction. There we go, that's 12 full revolutions. And with that, the drill bit is going to line up perfectly. I'm making these with 60 millimeter hole centers. That's about 2.5 inches. So I'm going to swap this out, put my pilot hole drill in, and then we'll drill the second hole. And I think we might just, tomorrow, install a digital readout on the mill. I really value having one of those on a milling machine. And I fortunately have all the components for it. So stay tuned, because I think in tomorrow's episode, we're going to put a DRO on the mill. And also, have a look at my new kicks. My Nix boots arrived a few weeks ago, and so I've been breaking them in. They're muddy from a good muddy British walk. And these are steel toes, so I feel extra safe. Big thank you to Nix for these. Right, let's drill some more holes. Alrighty, those holes are looking pretty good. To further explain the reason we're doing this, drilling 2 holes and welding in 2 pegs to make dies is going to be a hell of a lot easier than having to machine a shape like this. These dovetails, these grooves, that's going to take a lot more machining time than it's going to take to make our die plates with these 2 pegs. Righty-ho, from Yogo and I here at the shop, we're saying farewell. Thanks for watching. Thanks for coming along for these past 2 days. Be sure to check out Trade. Get 30% off your first bag of coffee. Thank you. Bye-bye.